This is section 10.2. We're going to find arc measures. A central angle of a circle is an angle whose vertex is the center of the circle. In the diagram, angle ACB is a central angle of circle C. So in the diagram, we're going to call that circle C because the center is point C. The central angle would be this angle, angle ACB. Notice how C is the vertex of the angle and the center of the circle. If the measure of angle ACB is less than 180, then the points on circle C that lie in the interior of angle ACB form what's called a minor arc with endpoints A and B. So it creates a portion of this circle, and this portion of the circle is less than half the circle. That's called a minor arc. And we're just going to name that arc AB. And the way you do that is you would write it like this. Write down your A and your B, and you put an arc over top. So it's not a segment, it's not a line, not a ray, it's an arc. And if you want to switch those letters, that's fine too. The points on circle C that do not lie on that minor arc AB form what's called a major arc with the endpoints A and B. So I'll use blue for this one. This arc is going to start at A and go the other direction. It's going to go through point D, and it's going to stop at point D. That's a major arc because it's bigger than half of the circle. Now, the way you're going to name that major arc is you're going to use 3 letters, starting at A, going through D, and stopping at B. That's arc ADB. A semicircle is an arc with endpoints that are the endpoints of a diameter. You can also think of that as half of your circle. And we'll use 3 letters to name a semicircle also. Okay, so naming arcs, pretty sure we just talked about that, but you name them with their endpoints. The minor arc associated with angle ACB is named arc AB. The major arcs and the semicircles are named by their endpoints and a point on the arc. So the major arc would be arc ADB. Arcs also have measures. The measure of a minor arc is the measure of its central angle. So the expression, would you have a little m in front of arc AB? You read that as measure of arc AB. So look at arc AB, it's blue. Notice how the central angle there is angle ACB. It has a measure of 50. Well, the measure of that arc is also going to be 50. Now, we also have a major arc here, and we'll call that arc ADB. If we want to find its measure, you're simply going to take 360 and subtract the measure of that minor arc. 360 because that's the measure of the entire circle. So that gives you 310. So that's the measure of our major arc, that green one, arc ADB. Let's try an example. Let's find measures of arcs. Find the measure of each arc of circle P, where segment RT is a diameter. Most of the time, I like to work directly on the diagram without even looking at the questions. If you know one central angle and it's part of a diameter, then you know the other central angle. So 180, that's the measure of the big central angle TPR. It's actually the diameter as well. Take away your 110. Okay, now I'll use some colors here to help with the arc measures. There's arc RS, that's a minor arc. Here's arc TS, that's a minor arc. Their measures are exactly the same as the measures of their central angles. I'll use this magenta to name this semicircle. Now, remember, we're going to name a semicircle with 3 letters, and it's not really possible there. So that purple arc is a semicircle. I'm just going to avoid naming it right now. What's the measure of arc RS? It's 110. What's the measure of arc RTS? Okay, now watch this. I'm going to use a different color here. I'm going to use yellow if it shows up well. I'm going to start at R. I'm going to go towards T. And I'm going to stop at S. What's the measure of that big yellow arc? You can add together the purple and the red if you want. 180 plus 70. That'll give you 250. But you could also do 360 minus the 110. Notice how that yellow arc covers just about the entire circle, minus that blue arc. Okay, part C, what is the measure of arc RST? So now we're going around the other way. I'll try green and see what that looks like. Start at R, go towards S, stop at T. Notice how that's your other semicircle. So that measure would just be 180.